Our next speaker is Maryam Soleimani with Surf, and her talk is entitled Who, What, Where, When, Auditing of Yoda IROTS Instances.
Hello, everyone. My name is Maryam Soleimani. I'm a member of the SURF Data Research Data Management Services. Uh, Welcome to the second presentation on the topic of IRODS auditing. Yesterday, we had another presentation by Groningen University. It is very nice to see that the IRODS auditing is receiving this attention. Today, I'm going to present the auditing that we applied on Yoda, which is a research data platform that we use in our team. We are providing Yoda service nationwide in the Netherlands. This facilitates researchers to manage their research data. It helps them to store, share, control access and permissions, manage the metadata, and preserve the data. Basically, it helps them to manage their research data throughout its life cycle. And we want to provide auditing on Yoda. We must ensure that our service remains secure and trustworthy. In order to support a high level of confidentiality and integrity, we need to make sure that we are providing auditing because we are mandated by some ISO rules and regulations. The reason behind this is that we want to make sure that we can investigate any incident that is going to happen to the data. And using that, we are going to be able to verify malicious attacks or any data leaks that is going to happen to the data, that might happen to the data. We are also able to provide the statistics, and that is something that our customers has asked us. We can report who has done what and when. This is what we are interested in to provide in our Yoda service. So customers has asked us to provide statistics on upload, download, delete, copy, and the login that is happening throughout the system when the users are using Yoda. So there was a couple of UGMs ago, there was a presentation by KU Leuven and about their auditing approach using the Debezium. It's a very nice presentation. I have provided the link for the slides. They tried to use the Debezium, and basically the idea is that the Debezium is going to capture all the changes that is going to happen on the database. And if there's a change happening in a database, there's going to be a message sent to a message broker, in this case, Kafka, and then you can capture all of these events. So what happens is that you have a message that says there has been a change in a database. You need to reverse engineer to see what, based on these changes, what was the action that has happened to the data. So that is a very complex system, and that is a very complex procedure. Also, we realized that there might be an untraceable action because there's going to, for example, in a delete situation, the user is going to delete a data object. There's going to be a change in the database, and there's going to be a message sent, but then you cannot recognize who has deleted this record from the database. So basically, you would miss that part of the information. We try to move on to IROD's audit plugin, and this is the plugin that is going to capture any changes that is going to happen in any PEP API. So obviously, when it is capturing everything in the PEP APIs, it's going to capture all of the actions, but it is not action-based. It's basically PEP-based. Then it's going to provide us a structured audit record and it's going to capture all of the information that is necessary to capture the action and send all of this information to a message broker. And part of this data is going to be, for example, an API number that is attached to this action. And basically, these are the information that we captured. These are important for us later on down the pipeline. This is the architecture that we are using to capture the audit information. So basically at start, audit plugin is going to send messages to the message broker, in our case, RabbitMQ. And for each PEP API is going to send a message. So, and actions such as iPut might get like 60 messages suddenly, all of them sent to the RabbitMQ. These messages are AMQ version 1 protocol. And then I have a converter script. This converter script is going to read them, basically consume these messages from the message broker, and then try to do some filtering. And then after the filtering and after just capturing all of these information, writes them in a log file. This is the way that we have selected to send all of our data to the log stash. So the log files are going to be written, and after that, FileBeat is going to pick them up and send them to log stash. Basically, this is the route, the flow of the information that we already had for our Grafana. It's a Elke stack that we were using. Seemed very natural. Write it in the log. FileBeat is going to pick it up, send it to Logstash, then to OpenSearch. We have an OpenSearch, and then we are going to have a Grafana dashboard to show all the statistics in graphs. We have the problem of huge influx of messages. I hope that you remember from yesterday's presentation as well. That was a problem there as well. This image that I have put is basically from the IRAS consortium. Here we are it's mentioned how many PEPs are going to be sent for a simple I-get. And they are basically kind of categorized into, for example, connection setup, authorization, existence check. So all of these are going to cause a lot of messages that are going to send via my pipeline. This causes a problem that we need to filter a lot in order to capture the information that we are interested in. And it's also cause a lot of traffic, cause a big log files that I need to handle. So for this reason, this was a hard part of this project that I was doing, basically capturing all of this information. So what I did is that I feel like I'm putting a huge something like a barrier in front of all of the messages, and then I just open it a bit and let messages in. So in order to find the relevant messages, I need to go through all of the messages that I receive and figure out if I have the information that I that I want for capturing the audit, and then send them down the pipeline. This slide also came up in the update of the IRADS consortium. This is about the IRADS policy plugin. The idea is that basically a group of these PEP APIs are going to be categorized together, and then there's going to be an event basically tagged to these groups of PEP APIs and then PEPs, and then it's going to say you can apply anything on that. So we are hoping to be able to use this in our audit in order to basically handle the huge influx of the messages that we had. We haven't yet used this IROS policy plugin. Has been recently released, I think in April. So we hope to be able to make use of this plugin soon. We had some more issues about the issues, some other things that I needed to handle using Yoda. Yoda provides a portal for the users to upload their data. So basically, there are multiple ways to upload a file. One of them can be the portal, one of them can be via the Davros, which yesterday we had another presentation about it, and also it can be pure I commands. Uh, each of these ways to upload the data can cause different category of messages that are going to be sent down the pipeline of auditing. For example, for the portal, Yoda is using an API call, and the API call goes to the server, and on the server, there is an MSI call that is going to upload the file. So the MSI is not going to be traceable by the audit plugin. I need to go back and make sure that I'm tracing the API call. So basically, in the case of the upload via the portal, I need to make sure that I'm capturing the message that is sent because of the API call. In the Davros case, I need to follow other messages. In the case of iCommand, I need to follow different set of messages. This causes the information that I am interested in to be in different fields. So basically, I'm not always looking for example, I don't know, file destination uh, field to capture the information that I want about the path of the file. And I need to capture them from multiple places. Let's go back to revisit the architecture. So while I was sending all the data from the audit plugin all the way to Logstash, I had some issues as well. So the RabbitMQ, the protocol that is being used is an AMQ version 1, and the Logstash couldn't receive the AMQ version 1. The plugin that I could use could receive messages with AMQ version 0.9, I think. So at first, I created a converter to read them from this version, make another queue with another protocol version, and send it through. Then I had the for the sake of making it easier not to open ports and stuff, I decided to change the functionality of my converter. When I receive and read all of the messages from RabbitMQ, write them in a file, and the file bit that I have is going to send them to Logstash. This way, I don't need to open ports to any VM that I have with the iRods to for the Logstash to be able to capture all of the data. So that's the way that I handled this situation as well. Then in the Grafana, so we created a dashboard for Grafana. Here again, we had to provide multiple dashboards for different ways that the user has uploaded the data or downloaded the data, whether it has been via the portal or other ways, Davros or other places. Then here I had another issue that the combination of the messages together could mean one action. So I couldn't count that I have received one message, then I have one count. So I had to aggregate these messages. For example, in the case of Davrods, there is going to be multiple messages sent in case the file is sent via chunks. So if there are multiple chunks, there's going to be multiple messages, and I need to aggregate them together and capture one upload, for example. And the information, again, I couldn't read one specific field. I needed to look for a specific action and then look for a specific field that I'm interested in and capture all of these together to provide the statistics for the user. So for the future work, at the moment, we are capturing a limited number of actions, which is the upload, download. We hope to extend it to more actions. We want to improve the performance and make use of the policy plugin. As I said, it would be very nice if we could aggregate all of these PEPs into a meaningful action and then capture that instead of multiple ways. We would like to have the messages kind of having a one single semantic meaning. So if I could summarize all of the information into one message, and then I would have one specific message being mapped to one single, for example, upload or download or any action, that would be nice. Next step is capturing the metadata changes also in the Grafana dashboard, and see how we can provide all of this information for the user as well. With that, I want to thank you, and I will accept questions.
Questions?
Yeah, thanks for the presentation. Just one question. I don't know, have you explored by chance Loki instead of using maybe some of the Logstash and all these stuff? Instead, Loki is from Grafana, and from my experience, it simplified a lot of using all tools. That's it. Simply.
So you just send all of the logs using the logging into Grafana.
Yes.
We haven't yet used it.
Okay.
Yeah, but that's a nice suggestion.
Question down here in front.
So I want to ask whether you see any performance impact when enabling the audit plugin, because we moved away from AMQP and so on, and we logged to syslog instead.
Okay, yes. We noticed the performance impact when we activated the audit plugin. We imposed a lot of the regular expression when we wanted to capture all of the PEPs to just capture what we need in order to make it more performant. But we could work, so it wasn't that obvious after some time. So I was like, okay, this seems natural.
Then I have a remark. So we also did a lot of work on auditing and converting the PEPs into actual actions. One colleague of mine did a lot of work, so you should reach out. Maybe you can reuse some of that.
That is very nice suggestion. I would definitely do that.
Any other questions? Yep.
It's more on this remark. It would be really nice if we would have in the iWords order plugin documentation just some examples on how to filter this. I think this is a general use case a lot of people have. I think this saves like 2 or 3 days for everybody of work, which does not have to be repeated. So if anybody feels responsible for audit plugin, have some example strings in there, would be really nice.
All right. Thank you.